So then we went back just now. We have mechanical energy is kinetic and potential energy. So this is one of the potential energy, which is gravitational potential energy. So remember just now that dude that stands on the hill, on top down here, and he is not moving. Right, remember just now that guy not moving, standing on that. So speed is 0. It doesn't mean that he has no energy at all and he's gonna just fall down from the hill. Yeah, what happens is he has something else called gravitational potential energy. So gravitational potential energy, the definition is here. So it means that something or someone or an object has gravitational potential energy because of the high position it is in the gravitational field. Or in simple words is, if you stand higher at a higher ground, you have more gravitational potential energy than someone who is standing on the floor, like ground level. So this one has lesser energy, lesser GPE. This one has more GPE. Where you stand determines how much GPE this person has. Are we okay?
Yeah.
So then again, we have a formula for my gravitational potential energy, which is over here, and you need to know. It's mass times gravitational field strength times height. Some books or some teachers use this as G is acceleration due to gravity. Then it will be 10 meters. No, then you will be, yeah, that is correct. It's 10 meters per. This G value is always 10 meters per second squared. In this case, it's always 10 Newton per kilogram. These two refers to the same thing. So G is gravitational field strength or acceleration due to gravity. Then this is GPE. And then this is height. Height is like this. You see the diagram here below. This one. I drew a box and then the box drops. And then it hits the ground here. It hits the ground eventually. So the position here, right, above the ground, this is height. It's a vertical height. Always vertical. Always star, always vertical height. So this is the height. Then mass, you know, is the mass of the object, which is mass of this. Then W equals to mg, simply just say that it's just a formula for weight. So the GPE, we can say that it's dependent on mass, dependent on G, dependent on height. That means the position the person is at. So the higher you stand above ground, that means the higher you have, the higher amount of GPE you have. Follow? Follow? Hello?
Yeah.
Okay, so let's do something. I have a flight of stairs. Okay, like this. I have position A, B, C. Then someone stands here, and of course a dog maybe or some creature is here like C. Then maybe say a cat stands here like B. Okay, so 5 meters. Who has the highest amount of gravitational potential energy?
Position C.
Yeah. Who has the lowest?
Guy.
The guy at A. Okay.
Yeah.
So if, okay, so this is this side, right? This line here is ground level. Okay. One level lower than the guy. So there's a paper box on here. Okay, box. Because it's on the ground, so the GPE will be 0. At the lowest point in your picture, it will be 0. Okay. EP of an object on the ground is 0. Then?
Yeah.
Okay, yeah. So there's something to note down here. You see the formula again, I deliberately placed it here. On this slope, down here you have a slope. Then we can have someone stand down here, right? So then in this case, we have this value h down here. In the diagram, they give you A and they give you B. How do you know which one is h that you're going to use for your formula?
The particle height.
A. Yeah, this one, okay? This one. So it's this. The A one, right? A is slanted and it's not vertical height, so you don't use that. Because sometimes students do choose the wrong number, then you get the answer wrong. Okay. Example 2. We have a ball of mass 0.5. So I write down 0.5. Then it's thrown to a height of 10. Then they say change in this. Change in GPE. Triangle means change. Then when they say change, right, that means you do have to measure initial and final. So initially, the ball is at the ground, on the ground. Where did that thing go? Okay, the ball is on the ground. Then after that, you throw it. Then it goes up 10 meters. This is the final. Then they say, what is the change? So change is the final energy minus the initial. So then we have our formula GPE is mass times gravity times that. Like that. So now, how much GPE do I have? Does this ball have at first?
0.
0.
Because it's on the ground. It has 0 GP.
Yeah, 0. Then, now this one, GPE is how much?
0.5 times 10 times 10.
Times 10 times 10. So we have 0.5 times 10 times 10.
50.
Yeah, right. So 50. This is like this. So the change will be 50 minus 0, 50 joules. Okay?
Yeah.
Nah, this one. You tell me what should I do? Tell me about it.
20 divided by 10 to find the mass.
So it's because of this, right? So this,
Mass equals
so
to
20 equals to mass times 10. Mass equals to 2 kilograms. And
2 times 10 times 2.
so you state the formula first, GPE equals to mass times G times H. So you say 2 times 10 times 2. Am I right? Mm. Mm. Now, got more lines to the question.
GPE equals to mg.
G P E equals to M G H. Then
0.5
mm-hmm.
times 10 times 8.
19. Yeah, 96. No issue. Wonderful.